Hi, my name is Joyce Kiboi. I'm a technologist in Civil Engineering Department in Public Health Engineering Lab. So today we are going to learn how to do water hardness test. Water hardness is done on samples from rivers, from streams. The reason why it is done, it is because we want to control the scaling in our water pipes, and also to make sure that the water that reaches the consumer is of good quality and does not cause problems when being used in the domestic use. When the water is being supplied, when the pipes are in the pipes, it will form scaling, and that would not be very good, especially to the consumer. Also, the water, when it is very soft, it forms corrosion to the pipes. So the pipes will corrode more oftenly, and replacing pipes, of course, is very expensive every now and then. So that is why we have to ensure that the water that is being supplied is of good quality, is not very hard, is not very soft, to have a balance. So today we are going to use the reagents that are here. The test that we are going to do is called complexometric titration. We are going to use EDTA, which means ethylene diamine tetraacetic acid, or EDTA. The EDTA is going to be used in this experiment as a chelating agent. It combines with the metals and forms a complex compound and separates now the metal from the water. So that way you're able to know the level of water hardness in that water. So we are going to also use ammonia solution as our buffer, because the experiment takes place best at high pH. So we are going to use the 1 ml so that we can raise the pH from maybe a lower pH to around 10, because the experiment takes place best at high pH. We are also going to use total hardness tablet, which is used as an indicator in this experiment. We will need a measuring cylinder to measure the volume of our sample, and a flask where we are going to do the titration. And now this is our sample, and also we will need a pipette and a burette. In the burette, we have the EDTA, which is our titrant. Okay, so we are going to measure 50 ml of the sample. $50 milliliters of the sample. Then we add 1 milliliter of ammonia buffer. And 1 total hardness tablet. And then using a flat end rod, we are going to crush the tablet. Make sure it is evenly distributed in the sample. So you form a wine red color, as you can see. So we titrate with EDTA from wine red to color blue. So once we get to color blue, that will be our end point. We will take the reading of the titer volume. So because we do not know the concentration or what to expect, we add the titrant dropwise to avoid over titration. So we already at the end point. So we take the reading of the titer volume. The reading is 1.1 of the titer volume. So we record. So our initial reading was 0. Then final reading is 1.1. So with this reading, now we will calculate the strength of our sample. The strength in terms of calcium and magnesium. Okay? Because that is what causes hardness. So the calculation, so we will use this formula to calculate now the strength of the sample. We have the volume of the sample, which is 50 mils, the one that we took, and then now the volume of the titer, the one that we have just gotten, which is 1.1, and then we have the concentration of EDTA, which is 0.01. I don't know if it is here. It is 0.01. So what we do not have is the concentration of the strength now of the metals, which is calcium and magnesium. So to calculate that, we will use the known to get to the unknown. We have 3 knowns. What we don't have is 1. We can easily calculate. Yeah. So once we get that, we are going to call it M2. Let's assume we get X as M2. Now that we have M2, we can calculate the concentration of the level of hardness of this water by multiplying now the M2 with the molecular weights of the metals, which is calcium and magnesium. It's very important to test these sample waters for hardness. At times we ignore them. We assume water from the borehole is good for drinking, we assume, but usually, most of the times it's not good. You will find if the water is very high, it has a high hardness level, even cleaning is hard. It will form scum with soap, so you'll end up using a lot of soap. It will discolor the colored colors. So that is why it's very important. And also corroding the pipes, forming scaling of the pipes. So you end up changing the pipes every so often. Yes. So it is a very important test. Yeah.